Welcome, everybody, to our webinar of the Center for Healthy and Durable Transportation in collaboration with the Missouri Center for Transportation Innovation. So we have three great speakers today that will talk about two different projects. And as usual, the participants don't have access to the microphone, but we have the Q&A box. And please put your questions during the presentations in the Q&A box. And as soon as the presentations are over, we will ask your questions. And you can also keep writing your questions while the speaker is answering the first ones. So without too much ado, I will start introducing our first project. So it's going to be the use of technology to enhance work zone safety and training. So we have Henry Brown and Zhu Qing with us as the speakers. Henry Brown is a research engineer at the University of Missouri, where he works on projects in a variety of areas, such as innovative geometric designs, work zones, and transportation safety. Henry also teaches the capstone course there. And prior to moving to Missouri in 2012, he obtained his bachelor's and master's degrees from Purdue and worked for 14 years as a highway engineer at the Indiana Department of Transportation. He's a registered professional engineer in both Indiana and Missouri. And Zhu Qing is a research scientist in the Department of Civil and Environmental Engineering at the University of Missouri-Columbia as well, specializing in transportation safety, human factors, and the application of immersive technologies such as virtual and augmented reality for workforce training and safety analysis. He has contributed to multiple federally and state DOT-funded research initiatives, including the iTrain and ZooSim platforms, which incorporate VR and visual simulation into a range of training and safety programs. Dr. Qing's work bridges academic research and practical implementation, aiming to enhance training effectiveness and improve roadway safety. So you can see we have great presenters. So I will turn it to Henry and Zhu to do their presentation.
Okay, thanks, Jackie, for the introduction, for the opportunity to present here at the webinar today. So Zhu and I are going to talk about some projects that involve using technology to improve work zone safety and training. So we're going to start giving an overview of Missouri Work Zone Center Safety of Excellence that's been formed here in Missouri to help improve work zone safety. And then I'm going to give an overview of MoDOT's pilot leader follower team truck mounted attenuator program, the evaluation that we did for that. And then Zhu's going to talk about using virtual reality for work zone training. So as far as work zone safety, there's a real need for research on work zone safety, and for the MOWZES Center that was formed. Work zones pose a lot of challenges to motorists, as well as non-motorized users and workers, due to various challenges such as lane reductions, narrow lanes and shoulders, lower speed limits, presence of workers, and so forth. So this graph just shows how fatalities and estimated injuries occurring in work zones have been increasing. So with that in mind, so the MOWZES Center was launched in 2023 as a part of the Missouri Center for Transportation, or MCTI. And basically the vision is to conduct research to identify and implement solutions to improve work zone safety. It also includes educating drivers about work zone safety, promoting some of the US DOT and Show Me Zero strategic objectives, include safe public, safe workers, safe design, safe systems, as well as critical infrastructure, cybersecurity. And the center also includes education, workforce development, and outreach. So the center also has an advisory board with representatives from different sectors, such as education, private sector, as well as the public sector. And so basically the themes for MOWZES are basically organized in four areas. The first is emerging technologies. So for example, smart work zones, connected automated vehicles. The second theme talks about data and tools, such as machine learning algorithms, crash modification factors for work zone countermeasures, um, crowdsourced data, data exchanges. The third theme touches on worker safety. So, for example, warning systems for workers to notify them that there's a vehicle entering the work zone, different types of countermeasures to improve safety for workers. And then lastly, vulnerable road users such as looking at pedestrians, bicyclists, ADA accommodations. So this is just some example projects, both current and completed. So a couple current projects we're currently looking at how to coordinate with towing companies to help improve incident response and clearance, to help improve safety, both for tow workers and for the traveling public. We're currently doing a study for MoDOT, basically looking at speeds and work zones and how fast drivers are going through work zones. So we're collecting data on speeds from various work zones in Missouri, as well as looking at different tools that can be used to determine if workers are present in a work zone, to help track workers in work zones for safety. As far as completed projects, I'll be talking about the leader follower TMA evaluation here in a minute. And Zee will be talking about the VR training. We've also looked at, for example, temporary rumble strips in work zones and whether those help reduce vehicle speeds, as well as looking at safety systems for drivers and TMA trucks. So the AMR leader follower TMA evaluation project. So the concern is worker injuries that can happen due to strikes of moving operations on the highway, such as striping. And so the last vehicle in this moving operation is most vulnerable to being hit from behind from distracted drivers. So basically, the goal of this system that MoDOT's been piloting and testing is to basically get the worker out of that follower vehicle to reduce the risk of a worker injury. So basically the system that MoDOT has been testing uses connected vehicle technology between a leader vehicle and a follower vehicle. So you can see here that the leader vehicle has a console that controls the system, as well as onboard control unit. It also has cameras, and then the follower vehicle has a steering actuator that controls the steering. It also has a control unit. It also has an emergency stop button, as well as an obstacle detection system. So again, this works through connected vehicle technology. So basically, the follower vehicle is using electronic crumbs from the leader vehicle to control a distance behind it and speed. So through this console here, the operator of the system can set a desired gap for how far back the follower vehicle should be, as well as a desired speed. So these TMAs are basically the system involves installing a retrofit kit. So it's basically a retrofit to existing vehicles. So it also has, for example, systems to detect obstacles. So if it sees an obstacle, to stop the vehicle. And it also, if it loses GPS signal, it'll go into what's called dead reckoning mode. And after 45 seconds of dead reckoning mode, the system will stop and has to be reinitialized. So basically, we evaluated this system for MoDOT through a literature review, survey of state DOTs. We interviewed some MoDOT personnel for their thoughts on the system, and also performed a field study. So for the field study, basically we rode with striping crews in both Springfield and Kansas City districts. So then we collected some video, as well as looked at log files that the system generates regarding like the system state and position and speed, and also Google Earth just to look at correlating events with features. So overall, we found the system was effective at maintaining the speed in the gap that was set by the operator. We did find that there were some instances where the system went into dead reckoning, especially going under bridges or sign trusses. So just to summarize the findings for the project, so through the survey, we found basically there's 4 DOTs that have implemented this. So Missouri, Rhode Island, Colorado, and North Dakota. And some other states are looking at developing systems. Virginia has been working on developing kind of their own system. Again, generally the system was generally effective at maintaining the gap in the speed that was set. So MODOT is currently in testing, so that they haven't actually taken the driver out of the follower vehicle yet, but that's the long-term goal. In the meantime, I know that the drivers mentioned that it helped them focus more on traffic behind them because they didn't have to really worry about the driving task. So again, we interviewed MODOT employees just to get their views on the system. They had some suggestions for possible enhancements, such as a remote reset feature, additional cameras to help the operator see more of what's going on, possibly a supplementary guidance system in case of loss of GPS signal. And just through our study and through looking at what other states have been doing, some of the challenges can be technical or non-technical. So some of the technical challenges, the GPS signal loss, need for situational awareness, for example, being on hills or curves. There's not too much available in terms of performance data, how to reset the system when the driver's not in the follower vehicle. And then as some states mentioned, tech challenges can be non-technical also, such as, for example, legislation, procurement, competing priorities, and then just awareness that the system is available and exists. There were some states in the survey that mentioned that they weren't aware that this system existed. But overall, the system is a promising way of using connected vehicle technology to improve safety for workers in moving work zones such as striping. And now I'll turn it over to Zhu for the VR.
Okay. So I'm going to talk about the VR program we have developed and also for the training purpose. So I couldn't ask a question, how many have you tried the VR before? So just assume that one, just so that more people actually they are playing with VR, and also VR is gaining popularity over the years. Although some people may mention the metaverse is still far away, but we do see the VR make a positive impact on the training. So we're trying to leverage the new technology for the training, and we are not going to replace the existing training, but we just want to incorporate the VR into existing training to enhance the students' learning experience and also enhance the training engagement. So they will be more active in the classroom learning and also help them to retain the knowledge. Because we have worked on this project, worked on this area almost over 8 years. So we started the project in 2017. So we were trying to support the national-wide adoption. So we have a more program and we work with more partners to promote the VR application. And meanwhile, all the new training course and the new content we develop actually is help us to reverse our existing program, and we're trying to keep updating our modules. Okay, on the right hand, you can see that there are some over the last couple of years, we have accumulated a lot of assets. We have a different rural, urban, highway, city street. We have a different assets. We have a different scenarios developed over the years. Next page. So currently we have 5 VR modules available for different course. For definitely, we start with MODAT, and we have the two VR training modules for the MODAT advanced work zone training and also the flagger training. We are working with also the ARTSAR and the ARTBAR under the Federal Highway Work Zone Safety Training Grant, and we are rolling out new courses. So, for example, the Traffic Control Supervisor (TCS), Flagger Instructor Training (FIT), and recently we roll out the Internal Traffic Control Technician (ITCT) training. Because due to the time constraint, I probably just like a pick MODAT Flagger and also the Internal Traffic Control Technician training as examples to show you the VR training, how it works. Next page. So for example, I'm just using the MODAT Flagger training as one example. So for example, in the VR training, the training content will include how to use the stop slow pedal to direct the traffic, and also the communication between the flagger, how they coordinate the work zone release or stop the traffic, and also more importantly, we add a violation case, how the flagger should respond to a traffic violation, and which is hard to prepare. I know that is part of training. The instructor will provide the standard response to that one, but it's quite hard to simulate that awareness and the situation. And we found that VR actually is quite good at handling such a situation. Another thing I want to mention is that over the last 5-10 years, we did see there's a rapid advance in the hardware for the VR development. Currently, we have most more advanced equipment. We have the HTC Vive Pro 2, which need to connect with the laptop, has the best resolution, and also we are also use Meta Crystal 3 a lot because they are the standalone version. You don't need a computer to run the program. It's very portable. We bring the device to the different training sites, and it's right plug and play. So no need for set up in the same environment, or maybe also set up a computer. Okay, next page. So here I just want to show you a video clip, just 1 minute, shows the scenarios, how it work. So for example, we have the I think now there's no audio instruction. Actually, we did have audio instruction. Before that, we just mentioned that we start work zone training, and there's a worker start to set up the taper behind you, so you need to
Please
stop the
release the
traffic.
traffic at your end and let Betty, the flagger at the other end of the work zone, know that you have released one gray sedan.
So this is a first-person view.
Hello, Betty. I've released the traffic on my end. It was just a single gray sedan.
And this one we just using the machine voice to demonstrate that what the students or the trainees need to share the information to the flagger at the other end. So you can see that, okay, how they switch the pedal and what the gesture they should do to release the traffic. Okay, next page. So that's just like a very interactive practicing scenarios. And this one, so you can play the video. So this one is like for the internal traffic control technicians. So we were trying to use this module to prevent the run over and the back over. For example, this is the field study. It's hard to set up like using the truck and to set up the traffic calm drum to simulate the worker around the truck. For example, this one, we work with ArtBar to set up a scenario. So you can see that we put a traffic calm around the vehicle, and the students can move the traffic cone and get in the vehicle to see where are the blind spot and what happens if there's a walker maybe tie their shoes in front of the vehicle. So they were trying to teach the students to be aware where the blind spot. But the problem is that it takes a lot of time to set up the scenario and also to move them around. Usually it's not feasible for each training. So Henry, could you go to the next page? So here, actually, if you can see that this is the module we designed. So we created a similar scenario, and students can move the traffic around, and after that they move everything set up, and we even used some dummy model, and you just need to push a button. We will send you inside the vehicle. So the vehicle, it's the same view as you see in the video, and you can get out of vehicle, then start to another run to adjustment to the location of the traffic jam or any the objects in this one. So we think, okay, this is definitely the time saving the setup. We provide the same practice to understand where the blind spots are, and we save a lot of time to set up a scenario, and also give the instructor and the students a lot of freedom to play around. And the more advanced, we can add actually later we add a lot of like moving objects. So rather than just like a statical objects around the vehicle, actually we add a few pedestrians just walk by, so you can see the walker getting in the view and disappeared from the view. So we just like trying to leverage the VR to make the training more realistic. I mean, it's not as realistic as a field study, but we're trying to using the detail and the realistic model to make the training more efficient. Okay, next page. And because we have five different training module, and we did the evaluation for each module, so we don't have one answer for entire project, but we look at all the data we collect over the 5 module. We find that 80%, 85%, the participants actually they think about the VR do provide a very realistic training experience, and they think it's a valuable tool. Look at their performance. We found that, okay, through the VR actually helps them to identify the more deficiency, and also helps them to uncover the gaps in the training, and also use the training using the performance data to help the instructors to provide feedback. And like I said, the technology is advancing year by year, and we also saw that the VR training acceptance rates is increasing over years.
Okay, thanks, Sue. So just to summarize, so again, there's real need for research in work zone safety. So through the MOWZES Center, we're doing that, as well as education, workforce development, tech transfer, and outreach. And then we've seen some specific examples of using technology for work zone safety research. So the using connected vehicles technology for leader follower TMAs to try and get the worker out of that last vehicle that's vulnerable to being hit during moving operations, such as striping, and then the use of virtual reality to enhance existing training for work zones, so such as work zone inspection, flagger, or preventing runovers or backovers. And so I think, if I understand correctly, we're going to do questions now after this part. So I've got a link to the MOWZES website on here if you want to learn more about different projects on work zone safety. So thank you for the opportunity to present.
All right. Thank you very much. Thanks. Very nice presentation. So as I said at the beginning, please use the Q&A box to type in your questions. And while people are typing their questions, I will start with a couple of them. So for the VR training, I've used that, and it takes some time to get used to the VR equipment itself. So in terms of the training time, do you see any difficulty in people learning how to use the VR, how to get acclimated to the VR first before they can actually start with the safety training?
That's actually a very good question. So we saw a lot of good improvements over years. At the very beginning, people have the motion sickness badly, especially at the very beginning years. We saw that because of the quality of the headsets was not good as today's. And sometimes they have some lagging when you're moving your head around. So we do see that one at the very early stage, we have that issue a lot. So we provide the warm-up scenarios to mitigate those challenges. So we will give some time for anyone to like 5 minutes to play with VR headsets. But recently, over the last 2 or 3 years, we found the new headsets like Meta Crystal 3, the HTC the Vive. They get the job done much better. So we now even shorten the shorter our warm-up scenario. So maybe just give it 1 minute or 2 minutes. Provide the audio instruction while they can play around with it. And right after that, they can jump into the training session. So just to avoid that such a situation, we add 1 minute or 2 minutes the warm-up scenario for each one, so they can adapt to that one a little bit. And also we control the entire training, each section, 2 to 5 minutes based on the training content. So we keep it short. We are not like running the module after module. So they can using one VR module for one scenario, 2 to 5 minutes, then you can take a break. And we have another training module, maybe after 30 minutes of class teaching, so they can get another one. So we trying to mitigate the time and also provide the warm-up to avoid such like a motion sickness or the virtual simulate I would say VR sickness.
Yeah. And I bet with as the workforce gets younger, I'm sure with the people coming up will be more, used to VR headsets as they become more widely available, I'm guessing.
Yeah, so we do see that some people said, okay, I don't need a warm-up, I'm good. I played the video game a lot.
Yeah. And one more question for Henry. So you maybe alluded it a little bit at the end of the TMA follower about the legal issues. So if there is a crash, the follower vehicle, so now we don't have a person in that truck, right? So we are making them safe. But if a car crashes into that follower, what will happen? So whose fault would that be? Or in the case of a legal question, so the second driver basically the second car doesn't have a driver, right? So is that something that people are looking at?
I think kind of the legal issues that we saw in the study is basically whether states actually just allow that vehicle to operate without an operator. So some of the states are interested in exploring this technology, but they currently don't have a law in the books that would allow that operator to be taken out of the vehicle. So that's kind of one of the challenges. I think the liability question, I think that's a good question. I'm not aware, we didn't come across in our research of any incidents of a actual automated TMA being hit. We did see in the video, just some near misses, like in our video cameras of, for example, distracted drivers not paying attention and changing lanes at the last minute.
Well, thank you very much. So let's see, I don't see any more questions in the Q&A box. So thank you very much. And with that, we'll switch to our next speaker, Dr. Haifeng Wen. The topic is utilization of recycled plastics for asphalt road construction. Dr. Wen is currently a professor in the Department of Civil and Environmental Engineering at Washington State University and serves as the director of the Washington State Transportation Research Center. He has served as both PI and co-PI on numerous state and national research projects related to the characterization and modeling of pavements and materials, including work funded by NCHRP, NSF, and Federal Highway Administration. His research has earned the Ashdoll High Value Research Award, and he was elected a Fellow of the American Society of Civil Engineers in 2022. So, Dr. Weng, I will turn it to you.
So good afternoon and good morning for the West Coast people. So I'm going to talk a little bit about the waste plastic for construction. My name is Heifang Wen with Washington State. I'd like to acknowledge my student, Osmita Thakur, and former student, graduate student, Qing Jiang for the work. So just a little bit of background. I think we all know pretty well the waste plastic is a concern for environment, and it's just not has been recycled well. If you look at the bar chart on the right, most waste plastics are kind of like dumped in the landfill or ocean water, so the recycling rate is very low. So when it comes to the recycled material or waste material, we often look to the construction industry simply because construction uses so much materials. There have been some studies on the use of the waste plastic materials, waste plastics for roadway construction, specifically in this case, asphalt road. So there's a different types of plastics. As you all know, there's like the ones for plastic bag, milk jar, water bottle, specifically, we have the HDP, LLDP, LDP, some of the waste plastics. The plastic bags are like the LDP, the PPPS, and the PET. The water bottle would be PET. So out of these, I think the PE has the best potential because of their melting rate temperature is a little bit low. There's different efforts to include plastics into the asphalt. One method is a wet method, so you melt the plastics with the plastics, blend with the liquid asphalt, we call the oil, and then mix with the rocks, and while they are hot. And so the other method is add the dry particles of the waste plastics, different shape, and with the rock and the liquid asphalt. So that's the dry method. There's also a little bit difference between the dry method and the modified dry. Is depend on when do you add the waste plastics in the process. Do you add it with the rock together, or add after the mixing of the rock and asphalt? So, or you can heat the rock really hot, hopefully melt the plastic a little bit better. So yeah, there have been few different processes. And engineering wise, there were a few studies, quite a bit of study worldwide, actually. So typically for the engineering performance, physics is that when you add the waste plastics, often we found that it helps the rotting resistance, which means in the summer you got the rotting, and adding plastics actually helps. So these are some of our study results. When you add waste plastics, the rot depth reduces. When you add different types waste plastics and different dosage, 1%, 3%, 2%. Another concern for the roadway is the cracking. The jury is still out on that. There's different findings, inconsistent. Some find it helps on the cracking resistance. Others like not so much. As you see from some of our results, also it's kind of like better or a little bit worse depending what the type and what's the dosage. And one thing we found that this one of our studies that when you add the PE plastics, it help the compaction. You see the air void in the materials reduces when you do the for the same compaction effort. So we found that pretty consistent, which is a good thing during the construction. You don't have a hard time getting the density compaction. So, but most of the studies in the past, most were focused on the lab mix. We know the lab materials are a little bit different from the real world material, especially in the plant. There's many factors can affect the results, like the temperature, the process, the scale, everything. So, and another question we also get asked is how does the use of the waste plastics in the roadway construction affect the environment, the water quality, air quality, and also how it affects the life cycle analysis. Right? So those are some questions. So for this study, we look at how the waste plastics affect the lab materials or plant produced material in terms of the engineering performance, like rotting, cracking, and I'll talk about that last year after many years of the efforts of coordination and communication studies. Finally, we were able to do a construction demonstration on the real road. So I show you, and then look at some results on the environmental impact we're using the waste plastics. Just give you a little bit of information on what we have done that on the in the lab. So we took a plant produced mixture. So we tried to use the plant mixture instead of the lab if we can. So for those of you who work in the area of the asphalt industry, it's a 1/2 inch aggregate size, 20% recycled asphalt binder, PG58 H22, asphalt content 5.5%. So there's also something like when we take the plant mix from the field and we added waste plastics. In this case, the blue one, that's kind of a mix of the LDPE and HDPE from a company called Driven Plastics. So we got the plastic, we added them manually in the lab and into that plant produce the mix and do the mixing, do the compaction in the lab. Of course, you have to heat them up, make the material softer. So then we went ahead, do the lab experiments on the engineering performance, look at all the engineering parameter, air void. If you're familiar with the asphalt, you know the VMA, VFA, those parameters. We also look at how it hold well in terms of rotting by putting on a wheel, rolling back and forth and high temperature in the water, see how it resists to the load and the rotting. And also, we break the sample to get the cracking performance at a little bit lower temperature to get a couple of engineering parameter. One of commonly used nowadays is the cracking tolerance index from the results. So, and we also look at the environmental impact. Here, instead of using the plant mix, we were using the laboratory produced mix. So basically, we mixed up ourselves from the scratch. So then we can monitor the air emission during the mixing process. Actually, this happened even before the construction, because one of the questions before we can proceed with the construction, the roadway construction, we have to answer to the agencies. Does this cause any environmental issue? So we did this first, try to show what's the environmental impact on the water quality, air quality. So we took the material, put in the water leaching, analyze the contaminants, those things. So we added used to up to 3%. In this case, the waste plastic is the PE, LDP, and HDP mix. And during the air quality study, you see the graduate student is all geared up with all this, sampler on his body while he was doing the mixing, playing with the material, which the hot material, there will be air emission. So with all this sampler, then we have the sample sent to a company in New York to analyze all the emissions related to air quality. So then for the water leaching, so we get the material and send it to a water quality lab to look at the leaching. And then also we had a sample. We used the little study tire machine, which is study tire is commonly used in the Pacific Northwest in winter for safety. So it kind of wear the roadway pretty quickly. So we have a little device in the lab you see the nail on the tire. It kind of wear the material, get into the kind of like a powder of the asphalt with the plastic in there. We collect it and send it to the lab to look at the microplastics, because there were some questions. Are the microplastics going to be produced and released into the environment? So we did all this analysis. Then we also look at a little bit the analysis in terms of from the cradle to gate approach. So it's there's a program called LCA PAIL. So we look at that in terms of the inventory. So we're not doing the full life cycle, but most of the time folks do the cradle to gate analysis. And then look at some of the results, again, and before the construction, we did we took some of the plant mix and look at the engineering performance, look at the sample. It kind of confirmed our previous study. Yes, we added the waste plastics, the PE specifically, PE is like a milk jar, or that's HDP or LDP, which is a plastic bag. So it does confirm that, air void is lower when you add with the plastics. And by the way, we didn't adjust the mix design. We kind of like drop this waste plastics in the mix. So, and then on the rotting performance in the summer, we also kind of confirm that when you add plastics to the dosage, it helped the rotting resistance based on this wheel test. And on the cracking one, and we have seen from the literature, it's kind of like inconsistent, but overall it's not too much difference in terms of the cracking resistance, up to 3%. So that's based on the mass of the mixture, not just on the oil. So with all those preliminary study in the lab, we after years of the coordination, finally, we were able to work with the agencies to pave a section of road. This is on the Eaton Boulevard in city of Battleground in Washington. If you look at the map on the upper right, so this is Portland, Oregon. Across the river, that's Washington, Vancouver. So Battleground is a little bit northeast of the Vancouver East Eaton Boulevard. So for the layout, so we had the regular HMA, the yellow one, no plastic. Then we have a section of the plastics, and then no plastic and plastic. So we are put them side by side so we can compare the performance. Another reason that we have two sections for each material is on the left side, there's a little bit more traffic here. So compared to the right half of the project, which is mostly just an open field. So that's why we feel like we needed to divide them into 4 sections instead of 2. So that was last September. We had the mixed design. I'm not going to bore you with those information. Based on the lab result, originally we said, well, 3% seems to be good, but we want to be a little bit conservative. Again, this is a real world construction, which is, it's like the project is about a 3/4 mile. Not terribly long, but it's still, pretty expensive, $500,000 construction. So we want to be a little bit conservative. We say we'll take half of the 3%. We go with 1.5%. For the existing road, you will see there's a lot of cracks, some little bit of potholes, not too much, and a little bit of rotting on the existing roadway. So this is the overlay project, which means the contractor started with the grinding 2 inches of the old road off, and then put it back another 2 inches of new material. And then we got the recycled PE from Jewin Plastics. They shipped the recycled plastics in that pretty big bag, plastic bag, super sack. And you'll see what they looks like, the plastics. And how do we include in the production? So we rented this feeder from a high-tech company called High-Tech. So you use the forklift, lift the super sack plastic, slice on the bottom, it drop into the hopper, and then this all automated. So is metered, so it can control the rate of the feed. So, and then you'll see on the picture on the right, and then it goes send through the blue hose here to the plant. The drum here is the plant. There's a opening for recycled asphalt, so it went into that place. So then before we do the street, the Eaton Boulevard, so we're a little bit careful. So we're not sure if it's going to work or not. And even though it has been tried a little bit in other places, but it's kind of new for us and in Washington. Plus, the plastic rate is pretty high. Typically, people use 0.5% or lower. In this case, we are going up like 1.5% based on the math, which is quite high. So before going to the street construction, so we did a little trial in the plant. There's some service road. So you'll see that we were using the 1.5%, and during construction it's okay, but we found that they were a little bit dragging and the segregation issue. And you will see that from the picture on the right in the middle. So apparently they made the mix a little bit hard to work with for the paving. So I'm glad we did that. And then when it come to the real construction, so we say, well, let's cut in half. So to 0.75% instead of 1.5%. 0.75% is still higher than almost all other projects I know. They typically use 0.5% based on the mix. So it's still pretty high. And then when they come to the construction, it seems to be working fine. Again, You have the bigger roller, do the compaction, you have the finishing roller, and it looks pretty nice, actually. We have not had an issue. And during the construction, we were checking the compaction, the density, and make sure meet the specs, and check the temperature. Even sometimes, it's getting a little bit cold, the mix, and went down to 250, it's still okay, no issue on the compaction. So as I mentioned, adding little the waste plastics helped on the construction compaction. So this is like what it looks like after the construction. So you won't, if I don't tell you, you won't notice there's a plastic or not. So it looks the same, looks pretty nice. With the plastic overall, even though it's not a long project, right? So it's only 3/4 mile. The plastic asphalt section is like 3/8 of a mile. But again, construction used a lot of materials. For that short stretch, we used like 6 tons with the plastics. That's quite a bit, especially you think like 6 tons with the plastic bag and milk jar. That's quite a bit. So overall, construction went smoothly. Met the specifications, and it was in the news, in the newspaper. Then one gentleman read the paper, the article, and contacted me. He works for a company, Dr. Paul Donovan. They do noise study, so he took his device, drove through the project, and check see if it make any difference on the noise. Apparently, according to him, there was no difference in the noise level. So again, went back, switch the gear to the environmental study. Again, as I was mentioning that the environmental study actually was before all this construction. So to answer the questions from the agencies and the public. So we did the air quality study. You have the no plastics. You have the 1%, the 3%, and check with the regulation. Seems we don't see any difference on the air quality with or without the plastic. They're all about the same. They all meet the Washington State PEL the limits. So that based on that, there was no concern. So again, they sampled like a couple of hours of the air emission during the mixing process. And then in terms of water quality, again, I'm not an expert on the environment, but this from the lab results, again, we don't see any issue on the water quality from the use of the waste plastics. So that's the. And then also we had another company look at the microplastics. Clearly with the device, the Raman and the PLM, they can see with the plastics, but they don't see any of the microplastics in the that powder from the study tire wear machine. So which is good. So but again, I just want to emphasize this was based on the lab produced mix. On the LCM apologize of there's again we didn't bump down the asphalt content, but overall you see with the inclusion of asphalt, the plastic, sorry, you see a reduction of the environmental impact on most of the cases. There's a couple of cases actually with the plastics it increased a little bit. The smoke here. We know that with the plastic, when we get it heated, it can has emission of itself. For asphalt production, we heat it pretty high, 300 Fahrenheit or even higher sometimes. So these are some preliminary environmental studies. To give a recap that. Including the recycled PE helped on the rotting, didn't change much on the cracking. And if we use a little bit too high of the recycled plastics, PE, it may make it a little bit harder for paving. So, but when we went down to 0.75%, there was no issue. We didn't see any impact on the air quality and the water quality based on those materials. Even though LC showed a couple of parameters went a little bit higher, but from the lab results, we didn't see any environmental impact. Again, so it took us so long, many years to finally have that construction project. We want to monitor the performance for long term, right? It takes some time for the roadway to show different performance. So that's why we want to monitor that. Again, the environmental study was based on a lab produced mix. So that was before the construction. And we want to study that when we were using the real world material and the production process, does it make any difference in terms of the environmental impact? Again, there was a lot of this truly collaborative, teamwork. There was a lot of agencies, institutions involved. CHDT for sure. Thank you for the sponsorship, especially on the environmental study. Washington State Transportation Improvement Board. That's the agency primarily funding that construction project. Qing County was helping do the initial initial engineering study, and the city battleground for make the construction happen. Drawing plastics for supplying the material plastics. Lakeside was the contractor doing the paving, and the WSU health units helped on the air quality. The Gaussian lab in New York was helping on the air quality sample analysis. EMSL was helping on the microplastics, and Anatech on the water quality. So again, there was a lot of agencies, a lot of coordination. Yes, their help are truly appreciated. So with that, that's the presentation on this topic. Thank you for your time and attention. So.
Thank you, Dr. Ryan. So great. This definitely gives me more motivation when I'm in my kitchen and trying to separate all those recyclables, because one of the things when you're recycling is, are they really going to do something with these recycled materials? And it's great to see that you can use 6 tons of it in 3/4 of a mile of a stretch. So that's a huge impact. So
yeah.
One question I had. So but you at the beginning of your presentation, you talked about those different materials, the PET, PP, all those different types of plastics. So in your project, were the plastics mixed, or were they all one type? In the actual field demonstration, is it all one type of plastic coming from one source?
No, according to the supplier, they take those PE from anywhere. So, but primarily, they have a relatively consistent supply. They can get it from like Home Depot or somewhere else. So although those are waste material, so is according to them is like a mix of LDP and HDP. But it may not be from the one source only. So yeah.
Okay. So we have another question. Do you intend to sample soil or water from the field section as part of the environmental monitoring?
That's a good question. We don't have a plan on the soil, so because it was an overlay, and they remove top couple inches. We don't get access to the bottom soil. Maybe on the side it's possible from the the runoff, maybe, but yeah, we didn't have a plan or on that. That would be great actually if we can do that. So.
Yeah, I would think with just the overlay, the surface runoff would be more of a question to look at. But Yeah, it's a good question. So, and then we have another one that says, would you recommend a special attention to the amount of wrap added regarding the percent of plastic? Is that important?
Yeah, I think so. In this case, I helped write the specification before the document went out for bidding by contractors. So at that time, we said, well, we have waste plastic already. We don't want to mess up with, too much recycled material. So I put in the specs and like 20% recycled asphalt and 0 recycled shingle. So yeah, when you add more of those recycled material, probably make it more complicated. So I would, yeah, from the workability issue we have seen, yeah, adding more of recycled asphalt may not help on the workability. So it may make it worse. So I would be a little bit careful adding more recycled material. So it would be nice environmental wise, but yeah, construction wise, probably a little bit careful.
So, you mentioned these were added either into the oil or during the mixing. So heated and added to the oil or during the mixing. In your field demonstration, this was just added cold into the mix, right?
Yeah, that's the one we call it the dry process. Yeah, that's the
Dry
great
process.
process. Yeah, forget to mention. So yeah.
All right. Another question is, our lab also has a PE test section in Columbia, Missouri. Our environmental engineers monitored the shoulder soil for PE migration for 3 years, and very small amounts detected so far, much less than the trash in the ditches. So, okay, so great, great to know that there wasn't significant in this runoff. And,
Right.
and which alludes also to the trash in the ditches, which is a big problem as well. But great. Yeah.
Yeah.
Oh, this looks like a very, very promising way of getting rid of those waste plastics. And even though you started with 3%, you ended up with with 1.5 and ended up with 0.75%. There
Yep.
may be some increases if you can figure out how to maybe finish it in a different process, because that was the only issue, right? The finishing.
Yeah. So actually, the supplier has some other recommendation. They can add some other agent in the asphalt. We may make it you can go a little bit higher. But at that time for this construction, I know agency just want to go simple and easy. Let's get it done first. Then we can do different ways. So yeah, I think there are probably different ways to make it a little bit higher. So in the lab, everything looks pretty, right? You can go up to 3%, no problem. That's why we need the construction, the real world construction. The construction, when it comes to construction, we realize, maybe not that aggressive, So let's dial down a little bit. So yeah.
Yeah. Until you go to that large scale, some issues you cannot detect in the lab. But
Yeah.
it's a great showcase. It shows that it can be done. It works. You don't have to change everything you're doing. Very similar process, and you can use it.
Yep. Yeah, exactly. That's the whole point, So yeah.
Great. All right. So I don't see any more questions here. Thank you very much. Thank you all our presenters and everybody that attended the session. As usual, the session is recorded and we'll place it in our YouTube channel. If you didn't have a chance to stay for the whole thing, you can just go back and rewatch. Thank you very much.